All right, so before we get into how to calculate, how to test these hypotheses, let's talk for a minute just briefly about errors in testing. So anytime decisions are made based on evidence or data, mistakes can be made. So we see this all the time in the news. They make movies about this. You know, you go to court, you get the wrong verdict, and all kinds of things can happen. So in court, a person who is truly guilty might get a not guilty verdict due to lack of evidence, which means a guilty person goes free. Another possible mistake is that someone who is innocent, they really didn't do it, might get a guilty verdict. They might have been set up or the evidence might be stacked against them. And so an innocent person goes to jail. So we see both instances of this all the time, again, in the news and in the movies. And those are errors. And sometimes we don't know if we've made the error until it's too late. So there's 4 different outcomes for hypothesis testing. And your book spells them out in 4 different sentences. I'm not going to read these to you because they're kind of jumbled and confusing. So it's much easier for me to explain this using the chart that the textbook provides. So we have the conclusion, which is based on the data, the court decision. And we have the reality. We have the truth. The thing about the truth is we may never know the truth. We may never know what the real truth is. So, in a conclusion, you either reject the null or you do not reject the null. If you do not reject the null, that means you have a not guilty verdict. If you reject the null, that means you got a guilty verdict. So those are the only 2 decisions in court. You either get guilty or not guilty. That's it. Now the truth, if the null is true, that means you're really innocent. You really didn't do it. And if the alternative is true, that means you're truly guilty. You really did do it. And I use murder as the example just because that stands out to us. So, let's think about this. If I am innocent, I should get a not guilty verdict. If I really didn't do it, I should get a not guilty verdict. So that would be a correct conclusion. If I'm innocent and I get a guilty verdict, that's not good. That's called a type 1 error. I'm innocent, but I got a guilty verdict. So that happens. If a guilty verdict happens, there's a chance that you made a type 1 error. Now, if I'm truly guilty, I really did it. Let's say I really killed somebody, or I really was speeding, or I really, whatever it might be. I'm truly guilty, whatever you did, but you get a not guilty verdict, that's also an error. That's called a type 2 error. Because if I'm guilty, if I truly did whatever I'm being accused of doing, I should get a guilty verdict. That is a correct conclusion. So what you need to remember for this class is if I reject the null, I could have made a type 1 error. If I fail to reject the null, if I do not reject the null, I could have made a type 2 error every time because we don't always know the truth. So the way I remember this, and this is silly, but it helps you remember. I know it's the end of the course, so I'm trying to give you guys whatever I can to help you remember it. I remember reject is 1 word, and it's a type 1 error. Do not reject is 2 words, or, more than 2 words, and so 2, type 2 error. So reject is 1 word, type 1 error. Fail to reject or don't reject, 2 words, type 2 error. That's a silly way to remember it, but it will help you remember. That's all you need to know about errors. I did have a student one semester that was really confused by this chart and confused by these statements. So I'm going to try a different way to explain it. You might not need this, but let me explain it one last way about errors. They're not that big of a deal in this class, but they are important just kind of in life to know how mistakes can be made. So, again, we have hypothesis test result, what the statistics say. This is, again, like the court decision. You're either guilty or not guilty. That's your court decision. And the truth, or what really happened, which we may never know. So if I get a guilty verdict and I am truly guilty, that's a correct decision. If I get a guilty verdict and I'm not guilty, I'm truly innocent, that is a type 1 error. If I get a not guilty verdict, but I'm truly guilty, that is a type 2 error. And if I get a not guilty verdict and I'm truly innocent, that is a correct decision. So that's just another way of explaining how errors work. Again, all you need to know for this class is type 1 comes from rejecting the null. Type 2 comes from not rejecting the null. Alright, so let's just look at errors real quick here. I'm not going to get into the details. Your textbook gets into much more details about errors. Again, we're keeping it pretty brief here. So same example with the headaches in the children. Let me make sure I've got everything correct here. Yes. So explain what it would mean to make a type 1 error with the same children getting headaches. So type 1 error is rejecting the null when the null is actually true. You didn't know it, you rejected it, but the null is actually true. So rejecting the null is saying that more children will get headaches. So remember, rejecting the null is supporting the alternative. So it's claiming that children will get more headaches from this medicine when actually they won't get more headaches. So in the medical field, sometimes they will not release a medication to the public if they think the side effect is going to be worse. So if they ran a test and said, I don't know, more children are going to get headaches, they might not release this medicine, even though in reality they wouldn't get more headaches. So a medication might not be released to the public. The other way an error can happen is a type 2 error, and that's failing to reject the null. When the null is not true. So failing to reject the null in this situation is saying children won't get more headaches, or more children will get headaches. So saying that that's not going to happen, saying, yeah, no, it's not greater than, it's okay, when in reality they will get more headaches. And we also see this in the news. When they think a medication's okay, oh, nothing's wrong with this medicine, they're not going to get more headaches, everything's good. They release the medication to the public and then they find out, oh, wait a minute, yes, they are going to get more headaches. This happens a lot with medication. They run the test, they think everything's good, then they release it to the public and find out, oh, there's a pretty bad side effect to that one. So you hear that in the news a lot as well. Alright, I don't want to harp on errors much more because it's not that big of a deal for our class. Really, that's what you need to know, type 1, type 2. Okay, so getting into actually running a hypothesis test. We're going to start with proportions, which again is the information we learned in 8.2, and then we'll do means after proportions. So before we get into specifically how to do this for proportions, let's just talk about running the test and what we're looking for. So when observed values are unlikely, under the assumption that the null hypothesis is true, we say that the results are statistically significant. And I'll show you on the curve what that means. So when the observed values are unlikely, under the assumption that the null hypothesis is true, we say the result is statistically significant, and we reject the null hypothesis. The level of significance will vary based on the problem. This is referred to as the alpha level. We've seen that little symbol before, alpha. Remember, that's the area in the tail. And so they're going to tell you at what level of significance are we going to reject the null. So what are we going to say is statistically significant? Each problem will give you a level of significance, and they call that the alpha level. So you'll probably see alpha equals some number. Any probability, which we start to call p-value, that is less than alpha is considered unlikely. We reject the null. Any probability greater than alpha is not considered unlikely, so we fail to reject the null. Now, your textbook gets into the classical approach and the p-value approach. I am only going to show you the p-value approach because I think that makes more sense. If you'd like to look up the classical approach, it is in your textbook and you can see how that works. The conclusions are the same. It's just what numbers you use to make your decision. I'm always going to use the p-values to make the decision. So what I want you to think about is our bell curve. We know the majority of the data is in the middle of the curve. So this is what we consider likely to happen. This is where the majority of the data fall. Most of our samples should fall in here. The tails are where the unlikely events happen. So anything in the upper or lower tail is unlikely to occur. We assume the middle is going to occur. It's unlikely that the tails are going to occur. So with this in mind, the null is where we're expecting our sample to fall. We're expecting our sample to fall in the middle where it's most likely. So that's where the null is. The alternative is in the tails. What are we trying to prove? We're trying to prove that our sample's in the tails. So our alpha level, this alpha, is this cutoff point. So likely events have larger probabilities or p-values. Unlikely events have smaller p-values. They're unlikely, so they have a small chance of occurring. And everything's symmetrical, so either tail is the same idea. So larger probabilities occur in the middle of the curve, smaller probabilities occur in the tails. So if your probability or p-value is less than alpha, we're saying that it's extreme, it's unlikely. If your p-value or probability is greater than alpha, it's not unlikely, it's in the middle, no big deal. So that's why we compare the p-value to the alpha. So if the probability, which again they start calling the p-value, is less than alpha, we reject. And if the p-value is greater than alpha, we fail to reject. And that's what you need to remember. Now the classical approach uses critical values, and again you can read about that on your own in the textbook. I want you to understand the p-value approach. So I've really streamlined this down to 3 main steps for this chapter. The first thing is to state the null and alternative hypothesis statements. Run the tests, and that's under stat tests, and we're going to use one prop z test for proportions, and we'll use a different test for means. So stat tests, for this one we're going to use option 5, one prop z test. Again, for means we'll use a different one. And then you're going to state your conclusion. You're going to reject or you're going to fail to reject. Remember, if you reject, you have enough evidence to support the alternative. If you fail to reject, you do not have enough evidence. So everything we talked about in 10.1. Let me make sure that's showing up on the camera. So if you reject, you have enough evidence to support the alternative, and if you fail to reject, you do not have enough evidence to support the alternative. I keep calling it HA. This textbook calls it H1. H1, the alternative hypothesis. So very simple. State your hypothesis, run your test, state your conclusion, done. So I've set these problems up very simply for you so that you don't have to stress too much about doing any of this by hand. And these problems are very wordy. This author is very particular about giving you all the background knowledge for each problem. We really don't need all this background knowledge, so I'm going to be a little precise here and just kind of cut down on all this. Not worried about any of that. Here's where the problem really starts. An official with the Illinois State Department of Education wonders whether less than half, that's what we're focusing on, less than half of the students in her state are prepared for college algebra. She obtains a simple random sample of 500 records who have taken the ACT and finds that 219 of them are prepared for college math. And again, we don't really care what that actually means. I'm just trying to pull out the important numbers here. So does this represent significant evidence that less than half of Illinois students are prepared for college math? Use the alpha 0.05 level of significance. Alright, so what we're trying to do is we're trying to test a proportion. Half is 50%, which means it's a proportion. We're going to assume that the baseline is 50%, and we're trying to prove that it's less than 50%, 0.5. So we're going to assume that it's 0.5, and we're trying to see if it's significantly less than 0.5. So we're going to run our tests. We're going to go to Stat, Tests in the calculator, and we're going to run a 1 prop z test. So let's see what that looks like in the calculator. Should be the same for either version. Stat, over to Tests. 1 prop z test is option 5 in your calculator. The proportion you're testing against, your P naught, is 0.5. X from the problem is the 219, and our sample size is 500. So 219 out of 500, we're trying to see if that's significantly less than a 0.5 proportion, and we're testing the less than side. So you have 3 options. You have not equal to, and you can push enter to select not equal to. Less than, you can push enter to select less than, or greater than, and you push enter to select greater than. We're going to match. So you match the symbol. If this is less than, you choose less than, and then you go down to calculate. So again, the null proportion is what you're testing against. Your x and your n come from your problem, and your proposition, or the thing you're trying to test, is the less than, and then calculate. Alright, so we tested less than. It gives you a z score and a p value. Your homework generally wants both. I just want the p value. So the z-score tells you how far away your sample is from the mean, which is pretty far away. The p-value is what I'm looking for. 0.002, round that to 8. P-hat we don't need for this. We just need that p-value. So our p-value, 0.0028, is less than alpha, which was 0.05. If it's less than alpha, we reject the null hypothesis, and there is sufficient evidence to support the alternative that less than half of those Illinois students are prepared for college algebra. And you can just put are prepared. I know it's a lot of writing for a math class. So again, state your null and alternative, run your test. Your homework's going to want that test statistic, so they call this the test statistic. I'm not as concerned about that. The thing I want you to focus on is your p-value. You compare that to your alpha. If your p-value is less than alpha, you reject the null, which means you do have enough evidence to support the alternative. And I just want you to write the alternative in words, the context of the alternative in words. All right, I'm going to stop there so don't get cut off, and I'll continue with the rest of the examples.